In this video, we will be talking about average acceleration and how to use it in equations of motion. Bill enters the freeway and speeds up from 30 kilometers per hour to 65 kilometers per hour in 10 seconds. How quickly on average did he speed up?
That question is essentially asking what his average acceleration was during that time. Acceleration is change in velocity over time, so the units are displacement over time divided by time, or displacement per time squared. So Bill's car starts at 30 kilometers per hour and ends up at 65 kilometers per hour. So his change in velocity is the final velocity minus the initial velocity, or 65 kilometers per hour minus 30 kilometers per hour, or 35 kilometers per hour. And it took him about 10 seconds, so his acceleration is 35 kilometers per hour divided by 10 seconds.
But before we calculate this acceleration, let's look at the units. This equation includes kilometers per hour and seconds, which means that we have two different units of time, hours and seconds. So let's try to convert this into meters per second per second. Our change in velocity is 35 kilometers per hour, and we want it to be meters per second. So first we'll multiply by 1 hour over 60 minutes and 1 minute over 60 seconds to convert hours to seconds. Then we'll multiply by 1,000 meters per kilometer to convert kilometers to meters. As you can see, the units for change in velocity cancel out to become meters per second.
If we multiply all of this out, our equation for average acceleration will have a constant unit of time. We get 9.72 meters per second divided by 10 seconds. This will turn out to be about 0.97 meters per second per second.
Now let's try out another problem, but this time you can do it on your own. If a catcher catches a baseball that was thrown by the pitcher at 40 meters per second, and he is able to stop the ball in 0.1 seconds, what is the average acceleration, or rather deceleration, of that ball? Remember that acceleration relates to displacement. So since displacement can be negative, so can acceleration. Pause the video, and when you return, we will go over the answer to this problem.
So we know that the catcher stopped the ball, right? So its final velocity is 0 meters per second, and its initial velocity is 40 meters per second. So to calculate the change in velocity, you do final velocity minus initial velocity. So 0 meters per second minus 40 meters per second equals negative 40 meters per second. It took the catcher 0.1 seconds to decelerate the ball. So the acceleration is change in v divided by time, or negative 40 meters per second divided by 0.1 seconds, or negative 400 meters per second per second. So to summarize, average acceleration is change in velocity divided by time, and it is a vector, meaning direction is taken into account. So acceleration can be positive or negative.